Researchers who study social learning are often asked, what is so special about social information? Why is it so much easier to learn from others than it is to learn on our own? To that I say, do you want to hear a ghost story? How about a psychological thriller? Our story starts with you. You're living in a community. You're sharing meals with friends, watching over family members, learning new skills from one another. Suddenly, everyone else vanishes without a trace. You're haunted by the skills you never bothered to learn, the ghosts of departed knowledge. You have to survive on your own, and it's terrifying. But why? Why is your isolation so lonely? When there's something strange in your neighborhood, who are you going to call? Ghost control researchers think they have the answer.
When we're trying to learn something new, how do we seek out information? Do we try it by ourselves? Do we look to see what other individuals are doing? And when we're copying others, I'm also really interested in how faithfully we copy and also whether we're selective about who we copy. Hi, I'm Lydia Hopper. I'm a psychologist and a primatologist, and I'm really interested in how individuals learn information from watching others. Specifically, as a psychologist, we look at social learning in two core ways. I study whether an individual can solve a new task by trial and error with no information, just to see what they do by themselves. And then I also present individuals, both humans and non-human animals, with tasks that they see another individual solving, to see if they're better able to learn in this circumstance using social information, and whether they copy the information that they are given.
If you recall our ghostly tale, when everyone vanished without a trace, the only learning possible was asocial learning, or learning from interacting with one's own environment. Dr. Hopper's studies focus on social learning, or learning by the observation of or interaction with another animal or its traces. There are many types of social learning for researchers to study, and they inevitably have to use some creative spirit in the designing stage.
Imitation is a very faithful copying. So there's bodily imitation, which means the individual observing another replicates all of their bodily actions. So if I raise my arm, you would also raise your arm. There can also be imitation in relation to the world around us, how we manipulate and move things. So for example, if I have a box that I need to open, and first of all, there's a rod that needs removing, and I twist it as I remove it, instead of just pulling out the rod, you would also twist that rod as you pull it out. You're really copying all the fine details that I'm doing. In contrast to imitation, where everything is very faithfully copied, emulation is about reaching the same goal or the same end state. So you're learning sort of about the process from watching another individual. So if somebody is trying to open a can, they could either lift the lid off or twist the lid off. How they do that is sort of irrelevant. The end goal is opening the can and getting the contents inside. And so when I emulate somebody else, I'm reaching that same end goal, opening the can, but I could do it in my own way. Indeed, I could even get a hammer and just smash it open, as long as the end result was the same.
1, 2, monkey see, monkey do. 3, 4, monkey slide the door.
If imitation is monkey see, monkey do it exactly, emulation is monkey see, monkey try it their way. You've probably heard of that little phrase to describe the ability of primates to copy. But is this a natural ability that all non-human animals have? Is it supernatural, where only some species can attain it? Or are we just seeing what we want to see, phantoms of human-like abilities that are not there? Luckily, researchers have devised a special test to detect if imitation and emulation behaviors in different species are ethereal or very real. Could you describe what a ghost control condition is in a dyadic social learning task?
So in this task, it's a box with a door on the front of it that can slide either to the left or the right. It doesn't matter which way you slide it, you get a reward either way. But what we're interested in here is, can observers learn that the door moves and that the door moves in a specific direction? So do they both learn and copy? So in these three conditions, the very first basic condition is one individual observing another moving the door. In the ghost control condition, we have an individual who's observing the door being moved remotely. So in this case, we tied fishing line to the door and pulled it either to the left or to the right. So the observer in both conditions sees the door move and only sees the door move in one direction, but it's either operated by another chimpanzee in this case, or just remotely. However, if the individuals in the ghost condition don't learn very well, it might be because they're by themselves. Maybe they're a little more nervous, a little more apprehensive about engaging with the task. So to create a sort of in-between condition, we have an enhanced ghost condition. And so in this condition, a chimpanzee observes the ghost condition that I just described, where the door is moved remotely with fishing line, but another individual is there with them to provide that social support that we know encourages exploration and learning. What we found was that in the social condition, all of the participants were really good at learning how to use the task. And more importantly, they copied what they had seen. So if they had seen the door move to the left, they did the same. Even though this was a completely arbitrary action for them, they still copied that demonstration. Interestingly though, in the ghost condition, we found still success. The individuals were able to move the door, but the fidelity of copying fell away completely. So here, it didn't matter which way they had seen the door move. They were less likely to copy that direction, and oftentimes actually explored moving the door in both directions rather than canalizing on a single response type. So what this tells us is that the social information not only enhanced learning, but really facilitated copying.
In Dr. Hopper's work with chimpanzees and humans, both species treated the social information differently than the ghost information. But what about in other species? Do they see ghosts? Rats are a highly social species that live in groups called mischiefs, where they play together, wrestle, and sleep together. Hayes et al. In 1994 tested rats on their success at copying a demonstrator when that demonstrator was social, another rat, or an invisible ghost. Rats who saw the social demonstrator move a joystick in only one direction copied that direction, while rats who saw the joystick move on its own in a single direction moved it themselves in both directions.
There seems to be something especially potent about seeing a social model demonstrate something that encourages that copying and matching by the observer.
Bumblebees are another very sociable group-living species. To test their behavioral and cognitive flexibility while learning, Laukala et al. In 2017 used live, or should I say hive, demonstrators and ghostly magnets to move a ball into a target location. Bees who saw a bumblebee demonstrator copied their behavior and moved a ball into the goal more quickly and successfully. Bees who saw a ghost were also successful, but less so and less efficient. So we've seen that social species like bees, chimps, and rats can copy social demonstrators. But what about solitary species?
Welcome to Dragon Park.
You want to play a game?
Kiz et al. In 2014 examined whether bearded dragons can imitate their peers and learn how to open a trapdoor in a specific direction. Only bearded dragons that observed a reptilian demonstrator were able to copy the exact movement of the door. Subjects who saw the ghost control instead, they weren't such clever girls, and they didn't, find a way. So what do these studies actually tell us about the importance of social information over phantom phenomena?
Social information is really important because it allows individuals to sort of not have to reinvent the wheel each time. They can see what others are doing, they can learn more efficiently and potentially more safely without making costly individual errors.
So the moral of the ghost story is this. Ghost control paradigms help researchers study how animals socially learn, whether they imitate, emulate, or find meaning in ghosts. I see ghost controls. But these silent frights have happy ends, for it is the rich social lives of animals that save them from the nightmare of having to go it alone. All work and no play would make for a very dull world indeed.